Here I am, solving more physics problems. An object has an acceleration of 2 meters per second squared. We want to know which of the following is a change in the speed of the object after 7 seconds. So, we're going to use V equals AT. So V is 2 times 7, which is 14. And we need this out to, this is 2 sig figs, this is 3 sig figs. We need it out to 2. That's going to give us answer A. Now here, we want to know which graph would produce a straight line. So once again, we have A is 4 pi squared r over t squared. So again, we will assume that all these are fixed. It's a circular path, so r doesn't change. So the constants here are 4 pi squared and r. And if we graph A versus 1 over t squared, we'll get a straight line with the slope equal to 4 pi squared r. All right, that's it for the last two multiple choice. And let's take a look at this little problem here, just to review what we did in class. So, very nice. And I'm just going to do the parts that I would actually kind of want to cover on the exam. So we have an object here. This little car is moving, and basically what's happening is this. We have this car accelerating from rest. So this is time equals, and you know what, I'm going to blow this up a little bit just so we can see a little bit better. Hopefully this, oh no, why does it do this to me? Like, I can't see the end of it. We'll shrink it and we'll blow it up again. It's so frustrating. There we go. So let's just get this let's get these oil drops labeled and we'll talk about what's going on. So apparently we have a car that's moving. Every 0.8 seconds it's dropping oil. And we're saying that 1 centimeter represents 4 meters. So we're going to take all our answers and multiply them by 4 at the end if we just use this little sheet here. So this is 0 seconds, 0.8, 1.6, 2.4, 3.2, 4.0, 4.8, and then 5.6 seconds. Very exciting. Now, we want to know, how can we tell if this car is speeding up? Well, here's how. The dots get further apart as time passes. Here we go. Now, so on the grid above, draw further dots to show where oil would have dripped if the drops had been produced from the time the car had started to move. This one is really weird, and I don't even know what they want from this. So I need to look this up later, but I'm not going to put this kind of a question on your exam where it's totally ambiguous. So we'll leave that. But we will determine the distance moved by the car during the first 5.6 seconds of its motion, which is out to here. Now let's go ahead and count squares. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Or we can count like this. Check it out. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 71, 2, 3, 4, 5. So we've got 15 centimeters worth of squares. I counted off 15 squares. We times this by 4 because we're told that we're told that we are, well, I don't know what that was. Yeah, just suddenly skipped to the back. Sorry about that. So we're told that it scales by 4 meters right there. So 15 centimeters times 4 gives me 60 meters worth of motion. And let's be really clear. How many sig figs do we need? We got 2 sig figs, 2 sig figs, 2 sig figs. So I'm going to say 60 point meters. Or if you prefer, you can do 6.0 times 10 to the 1 meters. Either one works. Now, let's determine the final constant speed. Here, we notice that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So we have 12 squares, and that's for the last speed. 12 squares, so 12 divided by 5 gives me 2.4 centimeters, times 4 gives me 9.6 meters, and we need to divide that by 0.8 seconds. And so, oh wow, that's great, Jennifer Corvo Castellanos. But we don't care. So 9.6 divided by 0.8 seconds, and that's going to give me 100. So it's going to give me 12 centimeters, 12 meters per second, like that. Awesome. Now the initial acceleration, here's how I would do this. I'm going to use the formula. I'm going to count off here. 1, 2, 3, 4, 5, 6, 7 squares. So how many centimeters is that? 7 divided by 5 is 1.4 centimeters times 4 gives me 5.6 meters. That's the distance that I cover. I'm going to use the formula S is 1/2 AT squared, and I'm going to use that to get the acceleration. So I have 5.6 equals 1/2 times A times t squared, which is 0.8 squared. And then when I simplify and solve for A, I'll get 17.5, but I need to get 2 sig figs for this. So this is going to round A to 18 meters per second squared. So I'll let you actually confirm the algebra on that. There's not a lot I want to say about this particular problem here. I might do it in another set of videos. I just want to say one small thing here. Distance, position, displacement, that letter's S. We're graphing against t squared. So we have S versus t squared, and I've only given you a very limited set of formulas. So what we'd expect you to see is that this is a graph of S equals 1/2 AT squared, and that the quantity given by the slope here, the slope should be equal to 1/2 A, because S equals 1/2 AT squared. Now we know that now the systematic error thing is not something we're going to cover in this unit. We'll do it a little bit later. But we know that there's a little bit of a problem here because we should start at 0. But the data is a straight line, so consistent. And that's really the idea. All right, so the results do suggest the distance is proportional to the time taken. Yes. We do get a straight line. And then if we were to calculate the acceleration, what I would say is get the slope here. That'll give you the acceleration. The slope will give you 1/2 of the acceleration. So we could actually do that, and I'm going to go ahead and just kind of show you here. So if we wanted to get the slope, we could actually do max min slope, but I'm actually going to kind of leave this as a general thing here because I don't want to actually do much more beyond this because I wouldn't put something this obnoxious on your test. So I wouldn't worry about going too much further on this. If I put a version of this problem on there, I would have you explain that the slope is 1/2 A, and I would give you a really I might just have you draw a line and calculate the slope yourself. I mean, I'm happy to kind of check that answer with you, but I wouldn't go much further with this. So that's it for the first practice test. I'm going to go ahead and put this online.